screen sharing.
Perfect. Beautiful. I can see it.
Okay.
I can hear you.
Okay. All the troubles we solved so smoothly. Okay. Thank you, everyone. I really appreciate that you joined me today. It's an honor that I can be there on our Pharma and provide you this workshop. Yeah, important topic. We will learn a little bit about building testing architecture for Shiny specifically. So that might be a little bit different than just regular R testing that might be you are familiar with. We will cover a lot of more topics. Before I start, a little kind of like sneak peek, why do we need tests? And I would like to present you some real pharma example that motivates me to kind of like spread this knowledge about testing and why this is important to the broader audience. Because yeah, I saw in the real cases that we are doing in Appsilon, why not having tests might harm you. Okay, so I of course simplified the example to not expose also some project details, but let's imagine that we have function that is doing something here. It's +5 and there is some x and you're adding the 5. Okay, like easy thing. But of course, in a real life example, the real scenario, the x was like super long. There was like a heavy calculations going on there, but the last part was adding something, just adding something. So someone, after like maintaining this code, decide that it will be good to just break the line. And if you break the line like that, it's of course fine. Everything works the same. However, what we spotted when we joined this project, so that was some legacy code that the pharma company was working on for some time. Then Appsilon joined the project and we started with building tests, and we realized that something is wrong with that function. It was always returning 5 because the break line was added just like that. And it was actually working on production for quite some time. It was hard to notice because that was some height of the label or something like this. And actually this result 5 was quite similar to what should be there. There wasn't like a big difference. However, of course, that might cause bigger problems, because that, of course, will return always 5, no matter what x is. And if automated tests were implemented before, that will be discovered like immediately after introducing that change, because tests would stop working. So that kind of reasoning why you need tests, maybe you had similar cases in your experience in the work that you're doing. Maybe this is maybe you're not so sure that you should have tests, so I can maybe with that example help you to realize that yeah, you should do tests, and how to do them, and how to do them efficiently, how to make sure that it's not any burden and it's not overwhelming you. This is what we will discuss during that workshop. Let me introduce myself quickly after I introduced the topic of the workshop. So my name is Marcin Dubel. I work in Appsilon for over 3 years. Before that, I worked as a Shiny developer for some pharmaceutical companies. I worked for consulting companies, and I also of course, I work as a staff engineer in Appsilon. I also act as an expert for some pharma companies as well. But yeah, my main interest as a staff engineer in Appsilon is making sure that our projects have the highest quality. We have some initiative called Appsilon Craftsmanship that I'm leading, and this is what we want to achieve, so that our projects are of the best quality. And that includes, of course, taking care of tests as well. If you would like to contact me, there are some details, and if you would like to have some fun and play a little game that is focused on helping us to prevent environment, you can check my Shark Attack Shiny game just for fun, maybe during the break. Okay, so that's me and agenda for our workshop. Yeah, we will spend 3 hours together. We will start with some theory about testing. I will explain like what are the test architecture, basically all those parts that we will cover today. We will start off, maybe not of course, but we will start with unit tests. So the most basic thing that you can use as a testing. Probably this is the first thing that comes to your mind if you think about testing, and probably this is something that you're familiar with if you ever worked with R code. But we will also go through some advanced topics, and I hope that I will put some like new ideas why those tests are useful. But because this is focused on Shiny, we will go and look at the Shiny project as a whole. So we will also do some data testing, reactivity testing, front-end testing, performance testing, and that should cover all the parts of the Shiny application as it is. That will be a workshop. So we plan some hands-on parts. There are this online setup, and the fact that there are that many of you, it means probably that I won't be able to like help you with any problems. I will. You can post all the problems on chat, and we will monitor them. Maybe during the break or something, I will answer them. Yeah, we will have 2 breaks. Approximately after like each hour of the workshop, there will be like 10 minutes break, mostly for me, but also I guess for you. I know that it might be a little bit early for some of you, so maybe you haven't got a chance to grab your coffee. If you will feel you can just continue doing some hands-on exercises during the break. Yeah, some more technical details. Yeah. There is, as it was mentioned, there is a RStudio Cloud. I think the links are probably like in the chat. If not, there should be. How can I see chat? Okay, I'm not sure whether I can see the chat.
Looking for the RStudio Cloud link.
Yeah, is it pasted on the chat?
Yeah, I can get it for you. I can get it.
Okay. Okay. Thank you. Yeah, so all the environment should be ready, and so there is a repository. Oh, here is the chat. Okay, I found it. All the repository that we will be using, it's there for you with all the environment set up. If you encounter any problems with RStudio Cloud, or maybe you would like to refer to this repository later, it's open. It's Appsilon public repository called Testing Workshop. Should be easy to remember. And you can go through the RStudio project wizard to take this from the version control and just restore the environment. If you're using the cloud, it is all done for you already. So I will be doing the hands-on like with you together. So I hope that you will join me while doing this. So this is testing it. There is like no one good answer for writing those test cases. Basically, your creativity is the only thing that can block you in the writing the test scenarios. So you can do it on your own. You can do it together with me. You can do it later and just watch me doing. We will be using the Rhino application. And so this is our testing workshop. Here, this is my RStudio, but this is the same thing you should see on the cloud. And there are 2 branches. So there is a main branch that we'll be using with like a pure Rhino application. And there is hands-on solution. So there is a branch with example solutions to all the tests that we will go through. So in case you won't be like following, you prefer to listen, or maybe you will write your tests on your own and you just want to compare them, you can always switch to that branch and yeah, just see the solutions. We will be using the main branch while working on this. I will explain a little bit what Rhino is and what I'm using right now. So the Rhino and those links, maybe I can paste as well in the chat, or maybe they are there already. Okay, thank you. So what the Rhino is, I don't want to open Rhino again. What the Rhino is, there is a package, open source package by Appsilon that basically creates a standard Shiny application structure for you. And it has already built in some really interesting solutions also for testing. And you can just use that for your project to have basically all the structure of the files and those solutions that as we are using them in Appsilon. I won't go into details, but for example, you can see that this is a pure Rhino application. It already has the tests. I will mention later what the Cypress is, but the test structure is already there. There is already RN fused for the reproducibility. There is stuff for linting your code, for styling using SAS. There are some nice solutions for organizing your code into the logic and view folders, and all the other files that you might use, you can put it there. And this is also using a box for managing modules and your dependencies inside modules, and making sure that they are nicely organized. I won't go into details. There are separated talks about Rhino that you can find on Appsilon YouTube channel, on our blog posts and website. But basically, you can treat this as a tool for the standard Shiny structure and some nice solutions. And this is what we will be using. Our example application is quite easy. The application that we'll be using for tests is, let me run this. I hope that it will not in the correct window. So, okay, I will move it here for you to see. So this is really simple application. We are just displaying values with a one single dropdown, but that will allow us to go through all the types of testing. Yeah, I don't want to like overwhelm you with the complexity of the application, so that we can focus on the solutions itself. Okay, so I hope that there are no big troubles with running this on cloud or getting this directly from our repository, and we can move on. Okay. So let's start with the archetypes of test architecture. So we will go from like the high level overview, and then we'll go into details. Basically, in literature, you can find those two architectures for the tests. So there is a testing pyramid that you can see on the left, and there is a testing cone that you can see on the right. Both are containing the same layers. So there are unit tests, integration tests, GUI tests or front-end tests, and automated and manual. What is the difference is how many of those tests, or like how big ratio of all the tests is the particular type of test. So in the pyramid, we have most of our tests are the unit tests for the logic, and we have just a few manual GUI tests. In the testing cone on the right, we have just a few unit tests and a lot of automated front-end tests and also manual tests. And usually what you can hear is that the testing pyramid is the way to go, and the testing cone is an anti-pattern. And this is true for the usual R project. For example, when you're building a package, you should have a lot of unit tests that should be covering like probably all your functions that you're using. And this is also true for the Shiny application if you are using a lot of logic. So there's a lot of business logic calculations, functions, and so on. However, the good Shiny application is free of logic in R there. What I mean is your R logic, heavy calculations, heavy stuff, it should be extracted outside of the Shiny project. It can be, yeah, separate package or, yeah, separate set of functions, and you should test them, of course. But your Shiny layer should be thin. And this is kind of like a good approach from the performance perspective, maintenance of the app, and so on. So if you are building just a Shiny application, probably there is not much logic to unit testing, and you should focus on the front-end tests, the reactivity tests, maybe your data tests that are not included here. Maybe we can treat them as part of integration tests. So all the other stuff that are kind of like visible for the user when they are using the application, to make sure that they won't encounter any troubles while using your application. The logic, of course, it should be treated separately and tested separately. In many cases, in the applications that we are building, Shiny application that we are building as Appsilon, sometimes there's like no logic at all, and it's all about just get data from the database and make it interactive and nicely let users play with the data, and maybe update the database. So there will be some unit testing, but it won't be the crucial part of the application. So both of those architectures I consider fine. It depends on your context that you're using. Especially when we are talking about Shiny, it might be that the other one is correct. The stuff that is not mentioned here, and I won't go into details, but user experience sessions is for Shiny applications, for R packages maybe as well, but for Shiny this is crucial to just get your users, sit down with them, and check whether playing with your application is intuitive, clear, yeah, whether they can find everything, that kind of stuff. So this is also what we highlight a lot in Appsilon, that this adoption is crucial for the success of the project. We won't, of course, do those tests as part of that workshop. It's the job that you need to do with the users, or even with your colleagues that haven't worked with the application. And this is called the hallway test, when you just ask your colleague for like 5 minutes, 10 minutes, going through your application and finding what is not intuitive there. Okay, coming back to tests, what is the most important here is the word automated. It is mentioned everywhere on the pyramid, and that's why I think both are correct. The only wrong architecture, whether it's pyramid or cone or whatever, like, I know, tower, whatever you may think, is if this is not automated, it won't work, because you will forget to run them. You will add some changes and you won't double check your tests. Your tests will be not updated, and you might end up with having like a lot of tests, but that no one ran them for like a half a year. And basically, if you try to run them, everything breaks. So you will need to like update all those hundreds of tests. So you just give up and forget about testing. Having the automated way of running your test, it's a key. And this is if you need to, if you will take away from that workshop like one message, I hope that it will be start your project with the automated architecture of tests. You can add them incrementally later, but as long as you already have those architecture of tests ready to be used, you are on a good way to actually start adding them. I saw a lot of cases when, you start a project and usually this is some proof of concept. Yeah, because we need to test whether this idea even works, or maybe we need to show something before we get bigger budget for expanding this application, or before we have a green light to put this onto production. So we start with some proof of concept. So testing, we don't want to use testing for now because we want to actually show a lot of features and prove that this is a cool idea for the project. And okay, you start, you have some nice application, then you get this green light to make it production, or you get the budget, and suddenly you realize that your application is that big that adding the tests will be like a big effort. I know it will take a few weeks, a month, and there is not permission to do this because you are used to deliver the features quickly, or maybe someone who is giving the budget is expecting that, okay, just a few more features and we will be good for production. And usually you give up adding tests at all because if you need to set up all the architecture from scratch and all the tests for all the application, when this is some mature project, it is just an overwhelming task. So starting with already given the test architecture, the structure automated, it's beneficial because then when you are adding your features, you can slowly, incrementally just add a few tests, and that will be like natural for you during working on tasks, features. If you're working on some feature, but you want to add a test for that, but you realize that before you add a test, you need to build the whole architecture and automate this, you just give up on testing and focus on the feature. And why Rhino, we consider Rhino a cool tool to be used is because it provides you the already built-in testing architecture and already connects this to the continuous integration. Not here. Here it's like a GitHub workflow for the there is a already built-in CI for the GitHub that you can just use. It's just there ready for you. So when you start a project with Rhino, it starts with the automated CI for your test, and the only job is to add your test while working. Okay. So that's the message I would like you to focus and take away from that workshops. All the other stuff is some solutions that you can use to build your test, different types of testing that you might use. But yeah, those are the things that like probably you can even Google with some effort. But this mindset of using tests from the beginning of the project and how to introduce them efficiently is something that you need to practice and have in mind, and it's not something that you will find out in Google. Okay, so let's go at the bottom of the pyramid or the cons. So we'll start with the very basic unit testing idea. So you are probably familiar. So there is an excellent solution for that for R and for Shiny as well. So there is a test.dat package that provides you a nice syntax for writing your tests and how to structure them. And basically those looks like as follows. So once you load your test.dat and you write a set of clauses that starts with test.dat, and then you with a plain English, you write what you want to test, like a meaningful description, and you write a set of expect clauses. Here we are testing the string length function. This is just some example from the basic test.dat, and you can expect equal what will be the value of your function compared to the known result. You write a set of those expect clauses. There are more of them. You can expect error, you can expect true, or you can expect all kind of stuff you can read about. Equal is the most common. There is much more in the testing that we will cover, but this is the general idea. You write what you want to test and what you are expecting. If the function value is modified, so if you remember my +5 example from the beginning, you will notice that actually the expect clauses are not matching at all, because it always returns 5 and not the value that we were expecting when running the function with some x value. Okay, how to use that? So there is for our packages, but yeah, I think that I added for our packages because for Shiny you can use Rhino, but that should work as well for Shiny. So you can use this to use test that, and that will automatically create you a directory with the folder structure there, and you can use DevTools to test your package. How it works is basically that you need to have a tests folder. Inside there, you need to have a test.dat folder that will be automatically recognized by the tests. And if you use that, there will be some test file. And the important part is to start your test files with the this prefix test, and that will be automatically recognized as the file with the test. And inside you write those test.dat clauses and expect equals. Okay, easy as that, and probably you are familiar with that. If not, there's a lot of things that you can read out there how to start with the test.dat. Okay, but what is the ultimate reasoning of using tests is to write better code, not to test itself. And this is maybe the second message I would like you to have, is that a lot of people, I heard that writing tests is maybe redundant, maybe the function, it's like, okay, tested that manually and I won't modify that function. And if I modify it, I will again test it manually. Well, first of all, you are losing a lot of time testing manually again and again. But the idea here, what I see the biggest value is that it allows us to write better code. And why is that? Because they help you to think carefully what your function is doing. When you start writing those expect clauses, you need to actually think, okay, what my function is doing. And when you think about this, you will start to thinking, okay, but what if I put to my function that edge case? What if suddenly my argument is empty string, or maybe if this is like empty vector, or maybe it's null? How my function will behave in all of those edge cases? If you're just writing your function, you probably won't come up with this, because you will go with the standard path that you had in mind initially. You might have heard about the approach called test-driven development, and this is exactly the same idea, that you start with your test and you first write your test for the function to figure out all those edge cases, that how it will behave, and to understand how your function will behave and what you are expecting this to be done. For the Shiny projects, I don't think that test-driven development is heavily used, mostly because usually in Shiny, yeah, you shouldn't have that logic. It's not that you're writing some functions like as in package. Usually you are just starting with something, maybe there is some user action changing the input, and then, okay, maybe this input is displayed. So simple thing, no need for the test driven, and maybe in time you see you are modifying somehow this input, and at one moment you realize that, okay, this is more complex, we need to extract this to the function. So then you have a function. Once you have a function, you need to unit test that, and then you start writing your unit testing. So it's kind of like tests are coming after writing a function, usually in Shiny. That's my experience. That's what I heard from other developers. But still, when you start writing those functions, you will realize a lot of edge cases. And especially if we are writing functions in Shiny that are reacting somehow to the user input, maybe, yeah, they provide some text in the text input. Maybe they are selecting some value, all that, or maybe they are providing some input as a file. all those cases when you need to cover. And the most important is that you act in a predictable way when the input is not as expected. Because the worst thing that you can do when building Shiny applications is that it looks like everything is fine, but the values are not correct. And this is exactly why you need unit testing to realize how your function will behave in this unexpected cases. And you want to avoid user that will see something that looks correctly, but it's not, because usually we use Shiny to make decisions so that not our coders use our applications to make decisions. And in case it is the values that you see there is it's a crap, you won't they won't notice this. If you are working on a script, or you are some researcher or data scientist, biologist, or anything, and you're just running your script, you are controlling better what you are providing as inputs. You might check this in our console again, whether this result makes sense or not. But for Shiny application, the users don't have that opportunity. So that's why it's even crucial to put tests there for all the cases. What's more, when you are writing a test for the function, you might think that the function is like perfect and fine. However, when you start writing the test, you will probably quickly notice that it's hard to write tests for your function, and this is because it's too complicated. Probably there is too much stuff going on inside, and it should be extracted to separate functions. Maybe there are some steps that can be modified, and this is all when that you might notice when you come back to your function and you notice that it's hard to write tests for that. It will allow you to simplify. I have an example right on the next slides. What's more, when you write the unit test, you are providing those descriptions what you are expecting. And this is ready to use the documentation for the future developers, or maybe future you, because you are writing what was the intention in case there is some specific argument provided. If we are lacking the tests and the new developer comes, and maybe they spotted some edge case, okay, maybe our argument is null, and we see some results, but we have no idea whether it should behave like that or not, like how it should operate. For pharma companies, I think that this is especially important, because you might collaborate with the developers that are not the domain experts, and they might just have no idea whether the results they are seeing is correct or not. The function returns something, but is it like correctly from the domain perspective? The developers might have no ideas, but if they see a test that how this is expected to behave, it's much easier for them to understand, okay, now when I manipulate this function, or maybe I refactor this, maybe I speed up this, then I know what to expect in every case, because I see this in a test. So that works like a documentation, ready documentation. Writing tests will help you to make function independent. So when you see that there is too much stuff going on, that suddenly you are using very different functions, and writing tests requires like maybe mocking up a lot of stuff. We'll go to the mocks in a minute. It will help you to extract some things, make independent, follow the single goal of the function principle, just to make it better. Okay, example of how the tests are helping us to improve the code. This is something that we like to present of how the refactoring of the code might happen. So let's say that we have the function that calculates total price, and this is a perfectly correct function. Given that the order CSV is like a table like that, it returns the correct values. What it should do is calculate some discount, depends on like what column is selected and what date it is, and then just sum up the discounted price. Yeah, then this function works fine. And if you just stop at that level, you might think, yeah, okay, this is my function and the task is done and we can proceed later. However, when you start writing tests for that function, you will notice a lot of things that should be fixed. For example, okay, there is some order CSV loaded inside function, and this is not fine because we cannot actually use that total price function for any other data set, just for that. And you would like to write your test based on some example that is maybe having some NAs inside the file that you're providing. So you will quickly realize that you cannot provide the file inside the function. You need to do this outside. Then you're writing your test and you notice, okay, but what if I select price C as a column? Yeah, maybe we are letting our users to provide the column, and what if the column name is wrong? My function, like, actually, it will return something because, okay, it's not price A, so the discount will be 0.3, and all the other stuff, okay, here probably with dplyr selected will be error. But still, it will behave, it won't be checked like whether the arguments are fine or not. It will try to continue calculations. Also, you will continue writing your test and you will notice that, okay, this discount calculation, there is some complicated logic there. Like it's checking the column and then it's comparing to some date. And what is date? What is 27th of November? Why? You will quickly realize that, okay, there is too much things going on here. We would like to extract the discount to the maybe separate function, and we would like to understand what the 27th of November is. And this is exactly all that stuff that you will realize while writing your function. Sometimes I'm showing like this step by step, but here I will go to the kind of like the final result of that exercise. What you can end up with, see, it's much longer. Yeah, okay, but it's much better function. So we extracted the discount here. We provided the date as argument. So maybe you would like to reuse that in different years, not just 2020. We added some checking of the arguments, and yeah, we have some nice error messages. What if the, for example, provided discount that you get from function, it's not in the values that we want? All that stuff that we would like to our functions have. Probably there is even more that we can introduce here. And we can have a lot of tests there to check how that will behave in case of different columns, like price C. Okay, we expect error. What if our orders or columns selected are null? What if there is something wrong with the order table? I will explain this mock and pictures later, but when you write those, you are realizing that your code has some problems. You also notice, okay, what is this 27th of November? That was a Black Friday. That's why there was a special discount. And I can read it clearly from that message here. Of course, they might be commenting the code, but commenting the code makes it a little bit clunky. So I have it here explained clearly. Okay. Hands-on? Yeah, hands-on. Let's write some tests probably. What do you think about writing tests? I hope that you can open the repository and the project there, and we will try to to write some tests. I will click the application. I don't need this running now. What we have here, what we can have for our testing. There is an application and there is some logic there, and there is a prepare.r script. So there is a logic in our application that is getting the column from our data set, and it's multiplying it by 1000 because of the values that are there. Let me just display you what the word fonts is. So we have some set of years, continents, and the values by I think this is for 1000 citizens. So if we multiply it by 1000, we will get the direct values. So that's why I multiplied it. But okay, there is some function there, and we would like to test this. And this is test prepare.r. So what we are doing in that case, we can go to our test logic. So it's here, go to our test.dat, and the test main is what is provided you by default by Rhino, just to show you that, just to build the structure and show you some example of test. We will just create a new file, new R script, and we will save this. And testing workshop app, not app, tests, test.dat. And of course, we need to save this using this prefix test. And we are using the script name. So test prepare is the script that we want to test. Usually you have one test script per R script that you are using. In your R script, you might have just a single function, maybe multiple functions if they are somehow logically connected. Probably if you extract the logic of one bigger function and you extract the logic to the like helper functions, you have them together in one script, and this is probably the way to go. Here it's really easy. We are adding this test prepare and we are saving it here. Okay, add it. Okay, what we might want to test, what this function is doing. So we are providing the matrix because this is the matrix. You can see it here, and we are providing the column, which column we would like to extract. So we are providing like the name of the continent and the value of the multiplier. We have some default value there. So what we might want to check is whether the whether it is multiplied by 10, by 1000. So we start by writing our test clauses. So test that, and we are providing the name of the test we want to have. Usually we are repeating our column name. It is like get column multiplied. Let's say that it returns column by name. Our standard case that if we provide the column and name, we can expect the that it will select that one column. Okay, and later we can provide any test that we want. If you work with test.dat before, usually that was something like context. Oh, it is still there, but yeah, it is superseded right now. It's not longer recommended. It will use the name of the file instead. Yeah, so the context was used that when we run the test, it will just write the more meaningful descriptions. That's why we provided those contexts. Right now, it will just use the file name. So it will be the test prepared, something wrong, test prepare, and it will use the description from the test. Okay, so we are giving up the context, and we want our get columns multiplied to be tested somehow. We need our data to be there. So let's say let's call it matrix as the name of the argument, and we need to have data sets. What was telephones or word phones? Word phones. So that we are providing the data for the test. I will show you on next slides, or maybe this is after break. Oh, yeah, this is after break, but I will show you why this is not fully correct to just use the same data as we are using in our application. For now, let's focus on the test itself. Once we have our matrix, let's say that we have the column, and now the standard approach, it will be just providing the column name. Let's say it will be Europe. However, that will be running our tests every time. Let's say that we have some CI implemented. It will all the time test the Europe column. And yeah, maybe something is fine with the Europe column, but we would like to test every column. So basically, it should not be anyhow dependent on which column we are selecting, as long as it is the column there. So actually, there is a new test idea that what will happen if we try to select a column that is not there. And if we have this idea, we will quickly notice that our function will return error, hopefully. So that might be a good motivator to improve our function. Let's say that in that case scenario, we want to test that returns column, let's say selected by correct name. So that will be our case. And as I said, we initially, when we start writing those tests, we get this idea, okay, but wait, what if the name is not correct? Okay, but here we try to test that case, that we have the correct name. And we don't want to provide the name like that, because yeah, that will always check the only one case. So let's say that we are just using sample of the call names of our matrix, sample one. So that will return on every run of the test, it will return the different column name. And that is the procedure that you are using in the advanced unit testing, that you try to randomize your test cases as much as possible. That helps you to identify the edge cases, because you might select randomly the case that you haven't thought about, but it's a valid case. Let's say that something is wrong if we select a column name with a dot, Mid-America. And if I just provide a case for the Europe, I won't notice that. Of course, I can write like case for every single column, but that might become complex if my data is like really, really long. Let's say that we have all the countries in the columns. So maybe running tests in the loop might be a solution. Selecting it randomly might be other solution that will help you to understand the edge cases. That also helped me once. I remember that we were in the project, we were randomly selecting a vector that will be input to the function. And that vector, once it was randomly selected with duplicated values. And that was not a case that we were thinking it might happen. We checked with the business, and yes, that might happen actually. So our tests were correct, and they helped us to realize that sometimes it might happen. And that was because we write it randomly, and in one of the tests when we ran it, it was selected. Okay, so that's the idea, but let's finish our task of writing the unit test here. So once we have our data, we have our selected column, and now we almost have everything that allows us to write our expect clause. So let's say that we are expecting equal. As you can see, there is a tons of those that you can try and you can play with. Failure, false, type, true. Type might be interesting also to check the classes. Identical, I think it's stronger than equal. Yeah, expect equal relaxes, ignore small numeric differences. Identical, it's stronger. Vector, error, message length, anything that you can expect. Equal, let's start with this. What we want to expect, so we want to expect that if from the matrix we select the selected column, that will be the same as if we use our get column multiplied. Let's use it, and we are providing the matrix, the selected column as a name, and value 1. So we want to our multiplier to be just 1, because in other tests we can check whether this, well, basically we are using that as well. Maybe this is what will happen if we are having matrix, we are having the selected column. Africa was selected actually. That is returning the values, and our get column multiplied. It's not loaded, of course. Our get column multiplied. The whole expect equal run. Our get column multiplied, it's the same. So yeah, actually I run it by hand, and you don't see any error messages, and this is fine if you're just running your test manually. If you run it and there will be a problem, you will get an error. There is, as you can see, it's also printing you what is mismatch, because it's comparing the vector of length 7, then we have 7 years, and it's nicely even producing you what is wrong. If we run the tests, let's say we've saved this file and we want to run it, I see that there should be we are missing the file for test.r. I'm not sure where it is, but we can add it quickly. Basically, we need to have test that run tests, or test here, something like this, and path will be probably it's tests. I've never done this manually, because this is what is provided you when you start the application. So that's why I'm not sure. Usually you don't need to write. Somehow this file was kind of lost, and we need to add it like one step further, and we need to write this as test.that.r. Should be here, and we can try running this. Fail. I believe in you. Probably there is a problem. Okay, I get it. What the problem is in our test main. So there is this example from the Rhino that we will modify later. So right now it's failing. Our test for the preparer, though, it's fine. Then we can see that the one test is passing, one is failing. Yeah, those messages that you can see in the test that are really motivating as well. We have the failure here, and this is expected because we don't have any hello as a message, because this is just what Rhino provided as an example. We will modify that later. However, our testing for the prepare works fine. And this is the output that you might expect when you're running your tests. Yeah, our test main.r is failing. This is the description, main server works. Okay, it fails. And this is the name of the file that is running fine. We have only one test there and it's okay. Of course, here it's not enough tests, and we even during writing the test, we identify a lot of other cases that we would like to test. Yeah, what if the column name is wrong? Maybe what is if the multiplier is negative, or maybe if the multiplier is string, and what if it's not provided, if the default value works correctly. We should check all that kind of stuff that we would like to test and write. Again, it's only your creativity and all the catch cases that you can think, and like how much time you have to write those tests can stop you. On hands-on solutions, there is more stuff that you can compare later. Okay, that will be for the unit testing. We will go back to this test that over and over again, but this is basically the logic behind the unit testing. Let's have a 9-minute break, okay, till 10 past whatever hour it is in your time zone. For me, it's 3 p.m. And now it's 2, so basically 10 past the hour, so 8 minutes break. Let's have it, and we will go back to some advanced topics for unit testing. Okay, so see you later. Okay, I'm back. I hope that you as well, and you had a chance to refresh a little bit. There was some knowledge to digest, and now we, with a little bit fresher heads, we can continue. We will cover 2 a little bit advanced concepts, although one advanced concept for unit testing with these randomly selected inputs we already covered. Now I would like to talk a little bit about mocks and fixtures. What are the mocks? Basically, for our simple case, as we had in our this testing workshop repository, we are having very straightforward function. So we have a function and there is some logic there inside. However, the functions that you are using now, or you will be building, there are much more complex, and probably they are using some helper functions. Let's call them that there is a parent function and there are some child functions that you are using inside. And this is actually great because we want to have this single goal of each function, and we want to extract logic to the separate functions, so that when we are going through the code and we are reading, we maybe in our discount case, we just want to see that, okay, right now in our calculation of total price, we are getting the discount. We don't care right now how this discount is calculated. The only thing important is that we are getting a discount, and we continue calculating our total price. If we are interested in the details of how the discount is calculated, we can go to the separate function get discount. However, in tests, when we are writing tests for our parent functions, such helpers or child functions might cause problems because their behavior it's hard to predict, and it might be that there is some issue in the child function that will affect our test for our parent function. And we will notice that there is something wrong in the parent function, and it will take us more time to debug the problem and find that it's actually in the child function problem. That was kind of that affected our parent function. So we want to avoid it. We want our test to be independent as our functions are independent. So that's why we are using mocks. And this is a tool for replacing the piece of code or to simplify the logic, simulate its behavior. It used to be, it still is the part of the testnet package, but there's also a mockery package that you can check, and it has the function called stub. So this is the same idea. It's a little bit more advanced than the what was implemented in testnet, so the with mock function. So if you are using that heavily, I recommend you checking the mockery package. Here I will use the with mock from the test package. It basically works the same in almost all the cases. Mockery, the stuff from mockery, it's somehow solves the problem for some base R functions that are not R code. But okay, whatever. The idea is what is important here. So let's say that we have a function called system name. This is a very simple function, and we just want to return the system name as and the name of the system. Let's say Linux. So what we are expecting is that it will return system name as Linux. However, it won't basically the example is Linux, that we want this to behave differently on a different environment. So if we run this function on Windows, we want it to return system name as Windows. That's the goal of the function. However, what to do in the tests, for example, if they are run on the CI and the server used there are based on maybe Linux, but locally you are using Windows, and like when you run test locally, you will need to expect different value than when the CI is running that. That might cause a problem. And this is because exactly the sysinfo is hard to predict how it will behave in different environments. But also the sysinfo is not a function that we want to test. It's just what we want to use. And we are pretty sure that it works fine, and we don't want to test. This is some base R function. It's definitely tested elsewhere. We are just using that, and we don't want to test that. And we just want to test our system name function. Whether it's correctly returning the value, the spaces are correct, things like that. So that's when the functions can be mocked. And we are using the with mock clause. So we are wrapping our test in the with mock inside the testnet. And we are specifying, like in the list, all the functions that we would like to simulate the behavior of. Here, we would like that sysinfo, wherever it is used within this with mock clause, that sysinfo returns, and we specify the function that will be used, and it will return the vector sysname equals anything, clever OS, anything, but this is static, and it won't be modified no matter where we will run that function. And this is just, we are using that vector with the sysname because this is how the sysinfo returns the value, and this is how we get the value of the vector, the sysname. It returns like probably more stuff. I don't remember right now, but we are just interested in that. So in our case, we can just get rid of the other stuff and just return the vector with sysname. This is what we need. So we simplified the logic of sysinfo, and we make it static, and we simulate its behavior to always return the same value. And so this is to make it independent. In case our function is built by us, we can just set it to be independent. I will show it on the next slide. But what's next? What next is that we continue with our usual expect equal, and we can run our system name function, the one that we want to test, and we can expect the value, and we can be sure that this is the value that we want to expect, no matter what sysinfo the normal one sysinfo will return. We will always check the clever OS. So now we can forget about the sysinfo, and we can focus on the logic that we provided in the system name. So later, if maybe someone by mistake or something like that, modify that function. Let's say that someone thinks that using paste 0 is a better idea here, and will provide the paste 0 here, but forget to add extra spaces. It will return like without space between is and clever, and we will spot this immediately in our tests. But that will be a system name problem. And we want to, exactly do this, to check the system name problem function or system name and not the child functions used there. In the final result, so this is the exactly same slide that I showed you with the total price example. You can see that we can use the with mock clause to mock, for example, the sysdate function. So sysdate was used to check whether we have the Black Friday day. So if we do not mock this function, our tests will run the same. Let's say that we are expecting get discount to return 0.2 and 0.3. However, on this 27th of November 2020, our tests will behave differently because suddenly our sysday will equal this special day and the return discount will be different. So that's why we don't want to use the sysdate as it is, but we want to always return the whatever that will be static. So this is the same case as with the sysname. The other case, if we want to test the function that we are writing, so let's say, as you remember, in our total price, we use the function that we extracted called getDiscount. But again, this getDiscount will behave differently, for example, on the Black Friday, or maybe we will modify later the logic of getDiscount, but this is the problem of the getDiscount test cases. And here we want to test the total price function. Here I'm here in that last test in the first column. We want to test the total price, not the get discount. So whatever changes happen to the get discount, it's the get discount problem. We need to update maybe the test for the get discount function. However, it should not affect our total price. Also, if something is broken in the get discount, we should get notified that something is wrong in the test for the get discount function, but total price should still be working the same as it is because nothing was modified. Everything works perfectly in the total price function. So we can mock our get discount to always return the same value. And when we know what will be the result of the get discount, we won't be surprised and we can actually check the logic of the expect equal. That allows us to separate our logic for functions, make them independent, make sure that they will behave kind of like stable, and that we won't need to chase for the bugs in the wrong places once they are happening. Okay, this is the mocking. Usually this is useful when you have something, some separate functions that you're using either from you created them or from outside, and your functions are more complex. Fixtures. What is the idea of fixtures? It's basically there are two things here. So each test should be independent, and this is why in each test we should repeat the input data that we are using. So in each test that statement, you should kind of start from scratch to avoid a situation that something from the one test are affecting what is happening in other tests. So this is happening rarely, but that will be really bad if you do some manipulations as a preparation for the test. So kind of to prepare your expect equal, and then it is affecting your other test. And maybe the order how you run those tests will be modifying the result. So in each test that clause, we want to start kind of fresh. And to start fresh, we would like to have kind of a nice systematic approach to build our input for the test, because we will repeat this over and over again. And that's why we need fixtures to kind of like create our input for the test. So here you can see that there is, let's say there is some sample data creator function that we define above all our tests, or maybe even separately in a separate script. And sometimes even what we were using in Appsilon is that we have like the whole class, R6 class, that has methods for creating those fixtures. So the samples of the input data that we'll be using for the tests. And here, as you can see, there is also this concept of randomly selecting our values. But this is also one more thing that we are using our fixtures, and why my solution here to just use the data was kind of like wrong, not following this fixtures idea. Because here I have no idea what inside word fonts is. I have no clue what there can be. Of course, I can print this and see. However, if I define this creator, it also works as a documentation. What I expect in my table to be. So here it's table, there is matrix, but basically I can see exactly, okay, those are the columns that are expected, and those are the values that it should follow, randomly selected, because I don't care about actual values inside usually. I just care about the structure. And that allows me to reproduce this case for each test separately. And also it's clear for me what I expect there to be. That is also helping to spot whenever our data that we are using in our real data that we are using is different to what we expect in our functions, because immediately we can see that, okay, suddenly my data that I input in our application, for example, has one extra column that is not used in my fixtures. And I see it immediately because I have everything plainly explained. If the datasets package modifies the word fonts, I won't spot it that there's something, or like I will see that my application is not working. But to get what I was expecting the word fonts look like when I was writing my function, and what it looks like right now, okay, maybe I will need to compare the versions of the datasets package, something like that. If I have a fixture for my data, that will be super clear that, okay, right now the word fonts looks like that. I was expecting those kind of columns. And yeah, that's why my application is not working anymore. How we are using this, it's really simple. It's just like you are using your data creator to use it here. This is some fake example. Let's take a look. Maybe here it will be better. Here. So there are mock examples. So again, we are coming back to our get discount and the total price example. And here what we are using is that we are using fixture to have the incorrect input. We can have a separate fixture that is not on that slide. I see right now that there is an order data fixture that creates you the correct order, and you can use that to check whether the orders are fine on this kind of like stable test fixture. And here we can have a fixture for the incorrect data, and that helps us to see, okay, there are NAs or some different values, and we can expect some errors. This is also useful if your data that you're using is somehow dynamic. Maybe you, when you are using testing, maybe you are kind of like, capturing the real data, saving this as RDS and loading this to your tests. It's not a good idea because, again, you have no idea what is inside there. And when your data is modified, you need to save this RDS over and over again without this understanding what is changing. If you are using fixtures that you will have those changes explicitly, you will have everything in your commit history. What are your expectations about data? that might be reusable thing to make your application work in the offline mode. This is, by the way, something that I also recommend, that whatever you are using in the Shiny application on production, you have some offline mode for any case of database crash, or just to compare how this is working without database connection, or to speed up the development process. Maybe getting the all data, it's taking time, and just you modify something on the UI and you want to make it fast, so you are using the offline mode for with some fake data, and you can reuse your fixtures that you are using for tests. So there are a lot of benefits of that approach. I would say, in our case, if you would like to test this, there's a good case for this data set telephones. I think we won't do that right now because it's as easy as creating tables. It's not tested. You need to have a function that creates a table with a given columns values. You can create also the incorrect fixtures, but again, this is some tables creation, or in our case, the matrix creation. So it's not connected with this. But the concept, I hope that you find useful. Speaking about data, connecting to database, using fake data, I think it's worth to proceed to the project test. So right now we will be looking on the applications in a broader perspective of how this works as a project. That Shiny application usually gets data from somewhere. There are some user interactions that are triggering functions, and you get your output, and users can make decisions. So, okay, we have this logic calculations covered by unit test. Okay, the user actions we will have covered by reactivity and the front-end test, and that will be later. But this data part, so usually the start of every application, it requires testing as well. And this is what we will cover with the help of data validator package, another open source package by Appsilon. It's not that I'm doing some advertising. I just think that this is really useful. And that was something that we developed as a part of working in our projects. And it proved to be useful for our clients over the years. This is kind of like a package that we're using for years. Quite useful and user-friendly. I will show you in a minute. But this is a key thing for Shiny applications, and this is usually not something that you know when you're just, or to what you pay attention when you are just writing R code. In Shiny applications, you might have basically two cases when you would like to test your data. You either get data dynamically from some API or directly from some database, and this database might change. And like before you are showing the results to the users, you might want to check whether this data is correct. There are mistakes. The famous story that we have in Appsilon is that for one of our clients, there was some new joiner in the company, and the job was to provide the discounts to the database. I don't recall what they were saying, but there were discounts, yeah. So that newcomer was not know the habits there, so discounts. So they provided this with like a minus. So let's say minus 0.1 will be a discount of 10% because it's reducing the price. So that was the logic behind this action. However, the discounts were provided in the database as like positive values. That, let's say that the fact that the price is lowered is in the discount itself, in its nature. So that was actually captured by the data validator, because there was a rule that before you start using this data on production application, you validate whether it's correct. And one of the validation rules was that discount values are between 0 and 1, so not negative. So that prevents for actually bumping the price up. So that's one of the story that we have. And that's one of the cases that you might want to use the data validator. You might have any complex setup of maybe if you're using RStudio Connect, you can have a scheduled job that is checking your database. And if the validation fails, it's sending automatically an email to some data maintainer. And if the validation is correct, you are passing this to the application, all kind of stuff. Or maybe inside your Shiny application, when it initializes, you do a quick check of the data. And maybe if something is wrong, there is like a pop-up with notification for the user that something is wrong. So again, each case might be different, and you might want to use it for your specific project, but that's important. The other case that I see how it's valuable, often when we build the Shiny projects, and this is probably what you also are using, we are allowing users to provide their own data, let's say in CSV format. And based on that their data, we are displaying some graphs or tables or calculations, statistics, whatever. However, we want to make sure that whatever they are providing, it's following some assumptions that we have about the data. In kind of like best of bad cases, our application will just crash. In the worst case, it will display the results that are looking kind of correct, but won't be correct. And that might affect in a bad, wrong decisions that the users will make based on the application. So this is crucial to actually, before you proceed, so after the user uploads the data, it goes through the validation. If everything seems right, then yeah, we can continue. We can show you the result of our calculations, graphs, whatever we are using there. Okay, so two cases how the data validator might be helpful, and how it works. You might be familiar with the assert_r package, and the validation is based on the assert_r. So you are just setting the rules about your columns, rows, anything that you want, in a way of kind of like building your pipes of validating your data. What data validator adds, it's making this a really nice report that you can share or you can preview your data. We will test this in a minute. We can check the results in a console, but this is not usually how your users will interact with the data, or this is not a way that you can easily share your results or maybe failures with some database manager or some business users that are providing data to the database, or your user of the application. So that's why the big advantage of data validator is the interactive HTML report that is showing you all the problems that is happening. We will generate one in a minute. And this is like just a file that you can send via email and share with someone, display in your Shiny application for the user, things like that. Recently in application, when I use data validator, when user applies the file, there is kind of like a check, and it's either like correct, passing, or something strong. And the user, if they want to check the details, whether it's passing or not, they can like click and it will open the model with the report that you can like go through all the rules that were checked, maybe to find like in which rows there were problems spotted. Hands-on. So switching to the RStudio, and we want to have the data tests. So we have our data that is our matrix of the phones, and we need to have a separate file. So that will be something different. We don't have a script, so we won't follow like the script name. Maybe in case you have some script that is preparing the data, you can do the validation at the end of this data preparation step. Maybe you have some logic that is getting this from the database or something that, you can just use the script name, but here we will add a file inside test that will be called test. Of course, you need to remember about that prefix, and we'll just call it data. And yes, the advantage of the data validator is that you can wrap this in a regular testnet structure, and it will just follow your single process of adding tests. So saving that file, it's added here, and this is what we will do. I'm not sure if I have loaded the libraries for data validator, because it's not like a part of the package itself, so we can call it them here. Also the assertor, because they will be needed. And we can start, and as usual, we are starting with our testnet clause, and with your English, it was word phones, let's call it word phones. And yeah, what follows follows our assumptions. Whatever, that will help us to identify that we are checking our world phones data. We can imagine that our world phones, we are getting this from this dataset package. So it's kind of like similar that we get this from some external source like database or external source users. Actually, that might be a case as well. And that users are providing. And here we need to, we need to have our data set. Let's say we'll just call it data set, and we are using the data sets word phone, word phones, okay. But that was a matrix, and actually to validate it better, we would like to make this the data frame. Of course, I remember this because I prepared for the workshop. This is something that you might get while trials and errors. So we have our data set, and we will write our validations. So kind of like what you saw. So there we are writing our validation stuff there. So we start with validate. Yes, validate. This is the function from data validator. Yes, we want to validate our data set, and we are providing the name. Yes, name for the validation. Just again with the plain text. Let's say it's again word phones dataset. Okay. And then we are building our pipe of checks. Let's say we can use all the different, let's say that we will use the validate if. All those functions you can find in the documentations. In time, you will definitely have like the experience in how to build them. And I know that there has all names, something that I plan to use during the workshop. So this is basically checking the column names. And let's say it has all the names. I probably won't type all of them, but say Europe. It's easy, Africa. Okay. It should check that it has those two at least. Of course, we should mention all of them. But let's write our next validation rules, and let's validate columns, and for example, not NA from assert or the other function. And we want, this is like just a function name that we are providing, and validate calls allows us to specify what calls we want to use it in a like regular deployer style, so we can select everything. Also one more thing, we can provide the description for each test, so the column names, and here we can have description. No NAs. Yeah, makes sense. Okay. So this is the regular validation, but we want to have the extra stuff needed for our report to be generated. Let's say, so the data validation report, and we need to have the add results. So at the end, we need to have add results. So there is a function from the data validation, add results to the report that we will create. And our report will be data. It was data validation report. And yeah, it does not require anything here. So it will create our basic report. So this is something that we can actually like run, and we will have our report. And if we print this, it will be printing the result, and there will be both our success. And we have two successful validations out of two. We see the table name. We can have it for multiple tables in the single report if we want, and a description of our test, and both are success. Yeah, because of course we have those. If we modify it a little bit, so it shouldn't be column Africa. Maybe I should create a new report. And then there is an error in column names because we don't have the Africa with double A at the end column. Okay. How we can wrap this in our test that, for example, so now with those results, you can play as you wish. Let's say that we want to save our validations and we want from report, there is a function get validations, and it will kind of like save your validations to the object. And now you can use the well-known expect. We can use expect true, for example, here. So our validations, we can actually check, okay, this is our validations, what we have there. So you can see like it's more stuff. That's probably, I'm not sure, maybe this is like duplicated because we run it twice, or this is for a single one. Yeah, it was duplicated because we run it twice. So here are our two tests. Yeah, I was confused. And we can, for example, expect true that validations type equals to success, and that will be a vector. So we can wrap this in the all function, and this is what we are expecting. It returns the nothing because this is true. If we modify our case to be like Africa again, and we run it again, and there will be just an error that it's not following our case. It will return the regular error. We can actually test it with our tested folder, that when we run this, it will be in our data. There is okay. Okay, I bring back Africa to regular Africa, so there is everything fine. We still have a problem in our main folder, and there is our prepare are still passing, and we have two correct files, and one is failing again. So this is great because our data, we have all the assumptions there. Of course, we can have more. Again, this is when your creativity is the limit, and maybe some rules that you discuss within a project, maybe all the stuff that you spot during working, building your functions, you can add this to your assumptions to the data. Yeah, if you're assuming something while writing function, you can just add it to your validator rules for your data set. And you can also have a lot of expect true clauses, maybe something more sophisticated than just the type. But the point is that you can have it together as a part of your regular testing structure. For example, you can have it on the same continuous integration tool as you were using earlier. So no need, if you are already having automated unit test, adding data validation test, it's no-brainer because you don't need to modify anything in your architecture. It will be run together with all your tests. And I think that this is beautiful. Now about those interactive testing. So we have our validations report, our report, and let's say that with report we have something like save HTML report. And this is a function that will create this nicely visual reporting. Okay, saved. I think it's somewhere like up there. I think it's here. There's this. Can I move this? I have some banner. Oh, maybe I will just modify it. Oh, that's clever. We can view it in web browser. It's just an HTML file, and you see that was just created there. And to show it to you, I will move it down there. So this is how it was opened. Of course, this is like some local stuff, but yeah, those are my two tests that are passing. I can see column names and not an ace. Everything passed. There are no details. Actually, let me try to generate this with our Africa case. And so that we have some problems. And now if I run the report, save HTML report. Okay, I hope that it's modified. Yes, I will share it with you. Sorry, it's opening on some different window. Okay, I will have one failed, one passed, column names. What's wrong there? Verification that Africa failed, one failure. I can see that has all names Africa. That was my failing in the first value there. Actually, for that, it's not like showing the rows. The best thing is if we expect something on rows or columns, because you can see the exact rows. But okay, let's move on with the different topics that I hope that you will find interesting as well. So data validation, simple. You are using assert clauses, you can display this, and what is the biggest advantage? You can share the results easily with not R coders or display this for your users. Having this, it's super easy. You are just adding that as part of your test that strategy. Hands-on, that was the hands-on that we are doing. And now the reactivity testing. What is this? This is solution from our studio, from Shiny. This is like built in Shiny, so there is no separate package. And yeah, I linked here the Mastering Shiny chapter 25.3 because this is some place where this is like nicely described. If you probably Google the reactivity testing, you will find it easily, but here it is. Some example from the textbook, this Mastering Shiny, and we will go to the hands-on in a minute. This is that kind of test that is keep failing for our when we are running our tests in our repository for testing workshop. What this is about? So as I mentioned at the beginning, in Shiny, we want the Shiny application to not have all this logic. There, it should be responsible mostly for the user interactions and what user is seeing. Okay, and so we might not have a lot of functions to do the unit testing. What we might have a lot is some reactivity and reactive clauses. So this like reactive, and you have all the stuff that you're reacting to, and you're returning some value. And later you are doing something with this reactive value. Let's say that, so this is the example of that. This is our application. It has in UI, it displays some text with min, and max. As you can see, this is a module, so we can use that in modules. And in our server, for that module, we provide some variable that is a reactive clause. We are checking that. Okay, in our server, we are creating another reactive that will be a range of that variable. And our outputs are, we are rendering text with those reactives. Okay. Easy thing. We are passing some reactive. Maybe this variable is depending on some what user is selecting, or maybe some slider with value or values, because we want to have it as a range. or maybe this is like vector that they are providing us when they're loading the CSV file, uploading to the application, whatever. Our module just accepting that and displays some statistics about that range. Okay, perfect. But this is not a function that we can do the unit testing. Of course, we can have a unit test for the range, whether range works correctly, but this is not the case. We want to check whether our output will behave correctly when the reactive is modified. So when our reactive var is modified, maybe someone is moving that slider, we want to test whether our output will behave correctly. And this is not something that you can cover with the unit testing, but this is actually the crucial part of your application, whether this is behaving or this reactivity is connected correctly. So how to do this? And this is when they introduced quite recently the test server functions. Again, we can wrap this in the test that. That's really nice because that can be, again, a part of our standard testing flow. Here in the example, this is an example from the book. In a minute, we'll do the other one. We are testing our server name, of course, and we are providing the X as a reactive value. Here we are setting this to the range of, so the vector from 1 to 10, so that we can calculate that range. And this session flash react is something that sometimes needs to be used. It is broadly described in the book, so I think you can read about this there. We can ignore it for now, and we can continue to our regular expect equal stuff. So we are expecting that our range val, and this is the other reactive that we are using in the module. As you can see, we are not defining this in the test itself. We know that in our module, somewhere server, there is such reactive, and we want to check whether this value is vector 1 to 10, because this is the range. This is the range of the variable. So we want to test whether this is happening like that, and we want to check whether our output mean will be the mean of that vector. And our output mean is render text of the mean of the var. And because this is text, we are using this as a string 5.5. And we can do this again with the different values of the variable x. Again, we can make it random and try to make it randomize, or we can repeat those tests for any different cases. Probably an interesting case to check this is what if the x is length 1, so it's a vector of just a single value, whether it returns the correct expected values. All that stuff that you can imagine, you can add here. Yeah, hands-on. So switching to console, and okay, this is okay. I don't want to save this with Africa, and what I want to have. And in our test, there is this test main that is added by the Rhino by default, just to show you that tests are there and tests are working. And this is exactly when it tests the server. And so this is testing this reactivity, and this is actually testing the whether the message, output message that is there is hello, because sorry, this is what you get when you do the plain Rhino application. There is some like hello world message of just hello in the application. Of course, something to start with. I modified that application with the content, but I haven't modified the test on purpose here because we will do it right now. There is some box used, so this is the box module that Rhino is using for making those independent. And you can treat this the same as using the library in your project, but library is more global, and this is more making it modules independent. You can read more about Rhino. In Rhino, this is nicely explained. We won't modify it. This is just fine. We will focus on our testing. Okay, We want to test our main server whether it works. We have our actually our test main. Where's my main? Here is my main. Our server is just called server, and this is our module ID. How this is called? This is like base Rhino. You can go to details of the other parts as well, but we want to check our title, how that will be generated, whether that will be generated correctly. So we have our render UI. So what we have here is this is based on some input region. So let's have it, and this is what we are doing. So here we can kind of like, it's a little bit like recording your actions that we will be doing. So in the example from the book, you were setting the reactive, and this is one way how your application might work, that you're wrapping your calculations in reactive, but you can of course need to sometimes to just simulate the user behavior by setting the different inputs. For example, in our case, this is a dropdown when you select the continent. So how it works in the test server, you're using session function called set inputs. And this is how it will. Probably let's use library Shiny, and that will probably, because this is a session object, this is not supporting me with the helper, but this is how it is called. I remember it's quite easy. What is our input name? And our input name is region. Okay. This is kind of like already namespace for that module, so we can just use the region without the name of the module. And our region, we will set this to Europe. I'm in Europe, so let's set this to the Europe. And then we can expect we'll expect equal, for example, our output title. Our output title, wouldn't we expect this to be, well, not that entirely. Okay, I too many, and we expect this to be Europe. Of course, again, maybe you should randomize this, or something's wrong. Okay, here I'm missing that. Maybe you should randomize this, but basically this is what you want to see. And this is what we spotted here. So expect equal output $mean, in our case, output title, and the value string. Here it won't work, and we can actually try to run this and see that this is not working. Yep, our main was expecting, can make it bigger. So as you can see, we're expecting equal that our title will be just this text, but it is throwing you some length mismatch and some like different attributes. And you can see target is HTML and current is character. And so what is happening here is that our case is a little bit more complicated than the from the book, because there it was almost output text that is returning text. In our case, our app main, it's the render UI. Render UI returns HTML. So we need to a little bit modify our test main, because we want to access it actually, and what is inside the HTML. And this is what I know because I'm using that. But you will, if you just, in case tests are not working, probably you're aware that you can just put a browser there. Maybe let's do this right now. And we can run these tests again. And we will get into the interactive state in the browse, because we put a browser there, and output title, we can actually access what is there and see, okay, why the tests are complaining. And okay, that's why, because our output title, it's more complicated because it's render UI, not render text. And what we see is that for render title, we can go to the HTML structure. And actually, we see that it returns the correct value, but how to get this? Well, we can use, for example, grep. So that is for finding the text inside the other text that has the different structure. So first, the text that we are looking for. Then where we are looking for the text here inside that. And because the grep, we are not comparing this to anything. We just want that our grep is true, so we can have that true there. And if we check is in this interactive mode, we can clearly see that okay, this is true because that was recognized. How this is useful, because like if we switch this input to the Europe, then and we see that this is the name that we are seeing there in the Europe, that it looks that it is fine. The wrong reactivity behavior is that we are setting the input region to be a Europe, but our title is still displaying some default one. I don't know what, North America is probably the default one there. So we will still see that it's North America here, not the Europe. Okay, removing my browser, saving the file, getting out of the browser, and okay, it will continue. So right now we can try everything works fine. So in that case, when we are using render UI, it's a little bit more complicated, but with some browser inside test that. And you can use that for any kind of tests, unit tests as well, that to run them in the interactive mode. And yeah, so this is the testing there. So here on the slides and in the book, you have like covered the case for the reactivity and the very simple output text. I wanted to show you a little bit more complicated with the render UI. For some complex stuff, you will be using that. It's really nice that we can test this reactivity, because this is not something that you can cover with your regular unit tests. And yeah, it's a nice introduction for the front-end testing that we will tackle after the break. So it's 5 past hour for me. So let's meet in 10 minutes. So 15 past whatever hours in your time zone. For me, it's 15 past 4 p.m. So see you in 10 minutes, and we will cover the testing of the front end. Okay, now I'm back and I'm not muted. I hope that you are back as well, ready for the final part. Approximately will take 45 minutes. We will cover front-end tests that will be with some hands-on. I hope that you will find this interesting. And some performance tests that we'll just discuss. Probably we want to improve the performance of our telephones application. Okay, what we've learned so far, we learned about the architecture of the test, and with this single very important message that we need to have this automated from the scratch, from the beginning of the application of the project. That will make it much easier to continue with your test. We've learned some advanced concepts about unit testing, and how unit testing is also helping us to write better code. And we've learned about data testing and the reactivity testing inside our Shiny application. So things that are specific for dealing with Shiny. Although like data testing, you can use this validation for any, even if you're using just the static scripts in your analysis, you can use the data validator as well. So the reactivity testing was kind of like very useful in checking whether some inputs and our application will react correctly to that input. But we can achieve kind of like the same result if we are using the front-end test. So we are comparing what will be actually displayed for the user when we are going through different scenarios and when we are doing the different changes in our application, when basically user is clicking there. So yeah, the reactivity testing is super useful, especially if you have some heavy logic in your reactivity. But at the end, what matters the most is what users are seeing. And that's why we will take use of front-end tests, two approaches that I will present. The first one, simpler one for the R users. It has some limitations, but it's much easier for us as R users to understand. This is Shiny Test 2. So this is the package that allows for recording of your test cases, of your test scenarios from our console, from the Shiny itself. And this is, yeah, I recommend you going there, and I recommend you also to check out the YouTube videos with the presentations of Shiny Test 2 by Barry Schlerke from our conference in Appsilon. It was somewhere in April, and also from the RStudio POSIT conference happening in July. Those are really nice presentations. That slide is important because you might be aware, if you are working with Shiny for some years, you might be aware of the Shiny test package. And this is the package named Shiny Test 2, because this is following the same idea. The screenshot here, it's actually from Shiny Test 1 package. I'm displaying this because in a minute we will see in practice how this looks like in Shiny Test 2, and you will be able to spot the differences. So Shiny Test 2, it's a really new opening for that idea. If you are using the Shiny test, you might found it not quite working, basically. So from my experience, yeah, it was working on a kind of like the examples in the README, but if you try to use it in your like real application, it was not working quite at all. It was causing a lot of troubles, so that's why they have this new opening. They modified the technology. They basically built this from scratch and call it Shiny Test 2. And this is much more useful, and we will use it in a minute. The biggest advantage is that you can just record this manually. Then the result is just an R code that you understand and modify, and yeah, a few more, and yeah, quickly to the hands-on, and let's try to record some testing. Okay, let's clean it. So we have our application, we have some tests, and right now we would like to use Shiny Test 2, and there is the function record test that we should start with. How it works. So we hit the record test, and what it is doing, it is opening the application. And now I need to wait while this is opening my application, and I need to find where it is open so that I can show it to you. Okay, why this is going some problems? Okay. This is the curse of the live demo sessions. Let's try again. Maybe it was some hiccup. No, so the usual thing that you do, you restart your R session. Yeah, that's relatively new package. I think it was firstly introduced in April, so maybe it has some hiccups still. Once we have the started R session, maybe that will work right now. Okay, full success. Always, if you have something that is not understandable, restart your R session. Okay, so what you see here, it's quite similar to what we were observing earlier. So I mean in the presentation, so what was there in the final Shiny test, but there is one really important difference. So if you look closely to the Shiny test, this sidebar, of course, you notice that there is the sidebar next to our application. There was only the option to expect screenshot. So how it worked before, it was capturing the exact image of what is displayed. And later, when you run your test, maybe after some modifications, it was comparing those two images. It is like just a PNG image. It was compared pixel by pixel. And it was all the time returning the failures because its computers does not work that way, that they are displaying exactly the same stuff pixel by pixel. There will be different fonts depending on what you are using. So here I'm running this on Mac, in Chrome on Mac, but the application will look a little bit different if I use Safari, and it will look a little bit different if you run this on Windows, just because the fonts might be different. And colors, it will be like not noticeable heavily by human eye. Of course, if you like take two of them, you will notice those differences, but it's not a big deal. But those screenshot snapshots will actually mark this as a problem. That's why they use this expect shiny values. So this is like the other approach that is kind of like understanding and saving as a JSON file the content of the page of your Shiny application. For example, what will be the content of your outputs? What will be the structure of your plot? What data is there used? All that that kind of data will be saved as JSON, and those JSONs will be compared, and that will allow us to get rid of those pixel by pixel problem. Okay, and so how it works? Quite easily. So you are just recording your scenario, clicking through the application as you would do this usual. And by the way, if you are doing this on some like complicated application and you want to have it, and it's especially important for the pharmaceutical companies and projects there, if you want this to be like super correct, you should have noted down your scenarios as a maybe some list of steps that you are doing for like reproducing this. This is something that manual testers are used to have it noted down, and later they are clicking manually for this. Here, thanks to Shiny Test 2, you will just go through that list, record each scenario as a separate test, and later you will just run it automatically and spot, because one of the tests will maybe causing problems, you will spot exactly which test it's causing them. Okay, so how this recording works? So let's say that we are switching back to Europe. And as you can see, I see like live update of how this is writing my test. And exactly, okay, it starts with some window size that might be important, of course, okay. And then after I did some action, so switched my region, it basically add a code to set inputs. And here it is using the module name app to identify correctly the exact input. If I'm reusing the same module, I need to understand which ID I'm modifying. So my app region was set to Europe, and that was my action. And that is the code that will be saved as a test case. And this is what we can later manually modify. So we don't, if we kind of like change the regions to be, I don't know, countries, and we want to modify the test, we don't need to kind of like record it again, but we can just go to the test and modify it. I will show you in a minute. Okay, and whenever we are ready, we are kind of like snapshotting what it is there. So we can expect shiny values, and we are adding this line to our test that right now it should compare it to the values, and we can also expect screenshot. Why not? However, if you are about to use one of those, I recommend shiny values, but still screenshots will be useful to understand maybe just quicker what is the difference. Okay, so that will be our our test case, and we would like to save it. And I would like to move this bar. I'm not sure if you're seeing this, but there is some bar from the is preventing me to do this. Let me just move it a little bit. We are saving this with some test name, and we might set the random seed, but we won't. We just click save test and exit. Okay, I hope that you saw it. There was just a name and exit button. Okay. What is opened here in my RStudio that you might saw, and this is actually allow me to editing. So this is my test that we will be using. So this is exactly what we did. So there was this new and setting the size. So that's what we saw that was initially. Then we set our inputs to Europe, expect value screenshot this window size. It's not what we want to do because that was me moving up just to be able to click the button. So we get rid of this and all the other stuff we can save. Okay. Actually, as you can see, it's run it automatically. There is some new stuff that was recorded. That's why the warning. There is adding new file snapshot because it was added, and files to our stuff. How this looks like. So first of all, that there are a few changes that you will notice once you start using Shiny test 2. First of all, when I go back to our test.r, so the file that we previously had there for our regular unit testing and our regular data testing and reactivity testing, right now it's modified by the Shiny test 2 to use the test app. Should we care? No, we shouldn't, because if we click this and we run this and our test.r is run, as you can see, all the tests are run again. So data, main, so our reactivity, prepare, so our unit testing, it's all running as it used to. So we don't need to modify anything in our, for example, CI, and if CI is just running whatever is in the test.r script, we will be fine. What is inside? So there are two things that were added inside. So first one is like some setup of the Shiny test, and this is something added here automatically. We don't need to care about that at all. There is a test Shiny test 2 file. So this is exactly what I was editing a minute ago, and this is exactly what we saw on the sidebar that was there. And as I told you, we can modify it here. So if we modify something in our application, that region was modified to country, I can just go there and modify it to country, and it will be Poland. Yeah, that's where I am. Country, there's type. And we can just save it, and we don't need to like record this again or anything. Yeah. Coming back to our region, Europe, and this is our file. And there is also the snaps folder. Yeah, it is recording the snaps, and this is actually recognizing my my Mac, that I'm using Mac. So if you and also the R version, the 4.2 is the R version that I'm using. 4.2.1 it's here. If I'm using the different R version and different operating system, there will be snaps saved in separate subfolders. When I ran those workshops, I tested this also on the 4.0.3 version. There was, I remember, a folder Mac 4.0, and later it added me Mac 4.2. I think this is what you can see on the hands-on solutions. There might be those two folders on this branch, hands-on solutions. Okay. So, and what is there? Okay, Shiny test 2, and you can see that it saved the images. Why 2 images? I don't know quite. The one is, okay, televisions Europe. So this is what we had. And the second one, okay, second one is also televisions, telephones by region Europe. Okay, whatever, there are 2. And there is also our JSON file And so this is what is when we have expect values. And this is what we will compare so that we avoid this pixel by pixel. And as you can see, for example, it is covering our reactivity case when we compared whether the title is correct. And we can see right now that, okay, once I set my input to Europe, I expect my title to be Europe. So kind of like that case that we tested with reactivity, it's also covered here, but there is more stuff. So for example, you can see some coordinates about the plots, and it should be comparing the plot. Okay. So this is the thing, and we can run it as our usual. And what if we modify something? Because rarely you have the application that you have, it's stable, nothing is changing on the front end, you can just record your test and everything is fine. It's a rare situation. Usually this is some like work in progress and you are keep modifying stuff. So yeah, first of all, you can just modify your test scenarios. You can record them from scratch. So you can even like get rid of the whole snaps folder and just say that I know that everything's working. Maybe I manually click through all the scenarios. I know that it's working, and just create me a new set of snapshots, both those JSONs and PNG. So basically run again whatever you have there. But also you might want to just check what is different, and let's go to the main.r and let's modify something. So let's modify, that will be the easiest thing. Let's not telephones, but maybe someone is a kind of like smartphones, okay. Maybe someone like who's very young, come in, like there are no telephones, there are only smartphones. So let's modify it to the smartphones, and let's see how our test will behave. I'm saving that, and I'm running our tests again. All this stuff is fine. Main is fine. No, okay, it's failing. Our Shiny tests are failing. Yeah, why the test main is fine? That's funny. We modify it. Okay, that's interesting, because it's not something that we see right now. It's not something that we should right now. Cell phones, okay, we might investigate later. However, at least our front-end test correctly failed. So we can see that JSON changed, and it's not as we were expecting, and also PNG, it's not the same. And what exactly is the difference? So we can go and investigate our JSONs and maybe take a look and maybe run the application and see. But there is also a nice function from the test that package, and it is snapshot review. That's the function. Okay, so as you can see, I put it my snapshot review, and the snapshot review is kind of like integrated with the snapshots I have in our Shiny test tool. And what I see is, let me make this bigger. What I see is comparison of this PNGs, how it was modified. So what I have recorded when I recorded test and saved my snaps, and what I have right now. And because there were differences, I can see the differences. This is not super helpful, but I can have toggle and I can just see. Okay, as you can see, it's automatically jumping from old to new. And it's clearly for me that I see what is causing problems with my testing. And okay, that might be something right now. This is probably something that I expect, or maybe not. If not, then I can fix what is causing the problem so that my tests start passing with the old version telephones. Or maybe this is just some change that I wanted to have, And I just want my tests to be updated, so I can just like accept this change, and it will be accepted as a new version. You should now compare to your smartphones. This new screenshot with smartphones. There is also an option of slider that is kind of like nice, that you can go like this, and maybe that will be easier for you to identify the changes. Toggle is, I think, nice difference. It's at least it's marking with red what are the differences. So right now it's not, but at least it's clear that something's wrong here. So because maybe maybe the changes are something that you want to accept. Maybe you don't. Probably if your tests are failing, it is not something that you were expecting to happen. If you were kind of like, if you expected that before, you probably fix your test already or record the new ones. So tests are failing. So this is the tool that can help you understand. And maybe this is something that, yeah, you are okay with, or maybe this is actual change that you were not fine. Maybe you modified some part of code and you affected, you know, with some like butterfly effect, you affected that the plot are not displayed. And suddenly you open your test and like there will be plot missing. And this is because you break something in the reactivity chain. And so that will kind of like prevent you from those checks. And yeah, especially if you have like a really complex applications, you like, we as a human beings, we are basically lazy, so we won't go through each and every scenario manually when we are just modifying one thing, one bug fix, or adding one feature here. And if we are not expecting that to affect other parts of the application, we won't go there and manually check this. We also won't run the tests like manually, that will go, and as we are doing right now, that I will click the run test. That's why it is extremely important to have it as a part of your CI, that you will be notified that something is going on with your test, and you might take a look. And so this is comparing the PNG. As I mentioned, it's also important to compare those JSON files because they are having like more details about your stuff that you're using. And here you can just see, okay, this is what is modified. In our head, the title was modified to smartphones, except of telephones. And yeah, you can just accept this if this is what you expected. In our case, no, this is not expected. We are having data from like 1950s and 1960s. So no, we want to use the name telephones actually. Okay, so I hope that you find it useful. And you can play around in whatever file that you're using, in whatever project that you're using, or with that project, and yeah, record some testing. Here there is not a lot to do, but as you saw, this is super easy to just record them, edit them, and run them. And yeah, what I love is that they are run again as a part of your regular tested architecture, and you are running all of those kind of tests, also the front-end test with the single command. Okay, coming back to our presentation, we had the hands-on on the snapshot review. This is what we covered. That was more a reminder for me to remember about that really useful function that you can compare your snapshots. Yeah, in case you want to record the full new one, you can just get rid of snaps, and it will prepare you the whole new set of your screenshots and those JSON files. If you just want to like reproduce the test. Okay, now maybe a few words about Cypress, because this is something that you can find in your Rhino application. So what it is, and to not be surprised a little bit. So inside tests, you probably noticed earlier, so there is some Cypress JSON by default and some Cypress folder. And this is the different approach for the front-end testing that we are having in Rhino as default. Why? Because it is like a much more mature product, the Cypress, the solution that you might want to use. It's also having more features, allowing you to actually like click on the application, and in the Shiny Test 2, you are more operating on, okay, you can set your input value, and basically that's all. Maybe you can like switch some tabs and all, but it's hard to, for example, react on some user clicks. So if you are using just Shiny, the Shiny Test 2 would be perfect for you. In case you have some very custom actions using JavaScript, for example, to react on some user clicks, double clicks, hoovers, something like that, you might need to have the more advanced and sophisticated tool for front-end testing as Cypress. What is so there is the whole website about Cypress you can read more about. So there are like all the features there. There is some dashboard. Dashboards might be available for priced solutions. I'm not sure. We are using like just the free one, and it's enough. However, to use this, you need to install some tools like Node.js, and that is why you don't have this on RStudio Cloud, because I wasn't able to install that stuff there. When you're using like your local machines, it shouldn't be any problem, or the server, that you can just install stuff. Just maybe example how this might look like. So just like example file of the Cypress. So this is again a set of the Cypress tests. So there is again like a prefix Cypress. Here's test one, just for example, and .js, because that will be using the JavaScript to operate. Rhino provides you like with the whole architecture, and it's just like you can add your tests there. Here it is taken from some other projects, so this is not connected to our telephones, but I just wanted to show you how it looks like. Again, it is doing some actions, like for example, to start, you just want to visit the page, like a default home one. If you want to visit like some subpages and you are using some routing, you can go to different subpages. Or you can have like some clicks. So for example, we are getting the input with the ID run1, and we are clicking that input, and we are expecting that our element with the ID out1, after 10,000 milliseconds, it should be visible. So we are expecting that to exist. And this is a set of tests. This is something different, that we expect that it will contain some text, that it will be visible. So again, a set of clauses. We start with the it. We start with the description, really similar. So this is our test that, this is our description. This is our function, right, in the like JavaScript style. We are doing some actions on the front end. So there we were setting inputs. Here we are clicking, and we can expect some values of the outputs, and yeah, we can check the text or something like that. Yeah, those Cypress testing, you can read about this more about the Cypress test, the Cypress website, and play around with this. However, that requires like a very different set of skills, some basic JavaScript knowledge, and like just getting used to that kind of syntax. As our users, you might be more just familiar with the regular test stuff. And if you are using just a Shiny application with regular kind of flow that user is selecting some values, you can just follow the Shiny test tool case, and it should be good to go. I recommend you to play a little bit with that. Okay. So that was our Cypress. We won't have a task for that. And the last topic that will be, or maybe there will be some hands-on, maybe we'll do, the performance testing. So this is kind of like the last part of your application. So when you are sure that everything works fine from the logic perspective, now your application should be ready to give it to the users. However, there might be two problems, and we will have solutions for both of them. So the first problem might be that your application is just working slowly, and the user experience is kind of like affected by that. Let's say that when they load something, they need to wait a long time for the result to be displayed. Maybe the app is initializing like really long. And maybe this is expected, and maybe this is okay. Maybe you're just dealing with some such heavy calculations and such heavy data that it is fine, and users are kind of like okay with that. Especially for the pharma cases, it might be like that because people there are used to some long processes for calculations because that is what they are used to. Still, it will be nice to speed this up wherever it's possible. And yeah, the question is where is possible and in what parts we should focus on. And for that, something called profiling is super useful. So that is our first case. So we will talk a little bit about the ProfVis package. The ProfVis package is displaying you a similar graph that you can see here. That is analyzing what operations in your functions are time consuming. Here, this is just about displaying the plot, and this is actually there is some model here calculated, and this is kind of like taking the majority of time here. How to use it with the Shiny applications? Do I have the package ProfVis here? No, so let's install it. So you don't have it as well on the cloud, so you need to install it. Okay. So how we can use it? So we ProfVis. We use the ProfVis function from the ProfVis package, and we need to run our application. So that will be, I will use the Shiny run app. So we are just running our application. So that opened, let me show you. That just opened my app here as regular. So I'm playing with my app. I go through my regular scenario, or maybe the scenario that I want to test. Then go through the standard one. But this is still like the profiling. So when I kill the application, it gets the interrupt, and it is displaying this nice plot that I can play with and see what is consuming my time. So we can see that, okay, something is happening at the very beginning. Then there is not for every function the sources are available, but we can see that, okay, for 20 milliseconds it is running our server, and it's doing this twice. Okay, so maybe that should not happen twice. We can investigate. Probably this is because we switched the input, and there is like more stuff going on here. Whether we can see, so this is our plot generation, and actually above you can see that render plot took 10 milliseconds, but actually to function generate plot, it took 60 milliseconds. Altogether, our running time, and this is like only capturing the running time of the functions. So regular R operations. So it doesn't matter how quickly you click on the application, don't worry. We can also like make it like this, so that will be simplified, so we can actually track what is causing our application to work so slowly, and we can identify the problem. And yeah, I can see it here that the function to generate plot, it's the most time-consuming thing in our application. Of course, here we don't care, but you can test it on your projects and see how it will behave. And why this is important. We might be often surprised what actual parts of the application are bottlenecks, and we want to avoid optimization of the parts of the code that are working fast enough, or maybe that are not triggered often and we can just forget about them and it's not a big deal, and we can focus on actual functions that are causing the problems. And it might be that they are slow and they need to be refactored, and it might be that there is some solutions that we can use to speed up the functionality, like futures or different loading package like Arrow or FST or others. Maybe we can outsource some operations to some API or directly to database. And maybe we should avoid going back to server, and we might try to do some stuff directly on the browser using JavaScript. So there is all those kind of options that you have to speed up your application, but you need to understand what to focus on, and this prov is helpful for testing your performance. It's not something that you can wrap up in your test that scenario, but yeah, it's something that you can run regularly and to capture what will be your time to execute this. We internally, but this is not open source, so I cannot share this with you. We internally have a tool, maybe it will be open sourced later. We use a tool to kind of like run this automatically and capture the scenarios and measuring the time, like comparing commit to commit or branch to branch, how the execution time speed up. So that is one kind of testing. So this is the testing of how your application behaves for a single user when you go there and you open your application, and how fast it is for you. So that should be like the same for you and the user. The changes might be depending on your machine that you're using. However, there is the second type of performance problem that you might have, and this is with how many concurrent users are using your application, and this is kind of like related to your infrastructure. So that is why we have a second part of test. So the loading test, and this is how your application is ready to handle multiple users, and this is kind of like a infrastructure problem. Because your server might not be ready to handle multiple users. With Shiny Load Test, you can just kind of like simulate the users, that multiple users. Here are the 4 users that are on that screenshot that are going into our application, and what will be the time for them to wait for some results. And we can compare this and how long they will wait, for example, for some homepage to load or additional files to be loaded. If we kind of like use a lot of traffic to our application. And there are 2 solutions for that. So there is Shiny Load Test that you can use for testing that on your application. It's not that easy to install it because it also requires the Shiny Canon. That is kind of like a system dependency that you need to install. So for installing this on some server that you don't have like full rights to install something, it might cause problems. You can read more about this, I think, also on our blog and somewhere on the Shiny Load Test page. how to install that. But there are two solutions that I would like to mention. So first of all, of course, you can like throw money at a problem, so you can increase your like server memory, you can have more servers instances, you can have like less users per session, so you can basically like increase your computational power of wherever you have deployed your application. For example, if you are using RStudio Connect to deploy, it has like those settings of like how much memory you want to spend, how many users per one session. So for how many users it will open like a new container with the new instance. Or you can just improve your application. So your application might be more performant. So for example, yeah, it won't go back to the server that often, and maybe some actions will be happening on the browser level. With JavaScript, this is possible with Shiny, and that might make your application more performant. So with the same computational power, you will be just able to use with more users, because it will be less demanding resources, your application, because how it is written. So you can solve this two ways, and how to test this, there is the Shiny load test. Okay, that was the last topic. So yeah, thank you. And yeah, most of you stayed till the end. I hope that you enjoyed the talk. I'm open to any comments, feedback. I know maybe the organizers will send me. I will check the chat in a minute. You can contact me directly on my mail, Twitter, anything. And yeah, again, the takeaway message, start your project with automated testing architecture, and it will pay off indefinitely in the future. It will just reduce your work and stress. Thank you again. I hope to see you later.